Okay, so what is the measurement that I asked you to do yesterday regarding the shape? Before you put them together, what did we calculate?
The surface area.
Surface area. And how did you work out the surface area of the whole object?
You found one area of one shape and
Yeah.
then you multiplied the rest.
If they were the
If they
same
were the same
shape. But do you remember, so, Marty, do that again in a minute. So what we did was we worked out the areas of any shapes that made up that object. So, for instance, if I've got the one on the screen that I want to, but if I go to this one, for instance, the icosahedron, right, what would be my method for working out the surface area of this? I'd work out the area of what shape? One triangle. And how about one triangle? Base multiplied by height, and then divide that by 2. Yeah, good. And then multiply that by? Is that 20? Okay, so we're going to look at a cylinder. You all know what a cylinder is, right? So, looking at a cylinder, what shapes make up a cylinder?
Two circles and a parallelogram.
Two circles and parallelogram. Another name for that parallelogram is a rectangle. Good. All right, so we need to work out the areas of two circles and a rectangle. Okay. Does it surprise you at all that a cylinder, like a curved, rounded shape, is a rectangle? Or not? No? Okay. All right, so let's think about how are we, put your scissors down, Tim. Let's focus on this one. One thing at a time. Yeah?
Do we need to do the triangles, or is that just
Yeah, the triangles are, because they're greyed out, they're the tabs, aren't they, to help them stick down. Yeah. So how do we work out the area of the circles? Well done. Good. Formula book that's coming in handy. You're using it. Good. So we've got the area of one of these, oh, it's going slow, is equal to pi multiplied by r squared. Now, it's quite difficult to get r on these circles. Why?
Because you don't know what the diameter is.
Oh, I wasn't even thinking that. We could measure the diameter, couldn't we? But what do I not know? I don't know exactly where the center is to get the radius. So what is a better way of finding the radius then? We would need to measure the diameter and then do what? Divide it by 2. Good. So what I want you to do is, could you measure the best you can the diameter of the circle? All right? So try and measure the diameter of the circle. All right, try and get it. Do it a couple of times, just check you've got it. And then you're going to divide that answer by 2.
Do you want to see centimeters or millimeters?
What do you think? What did we decide?
Centimeters. Okay.
Yeah? What is it? Oh, no, you don't need a compass at the moment. You've got a ruler. Just measure the ruler.
divided by 2?
I get you, but let's just measure the diameter at the moment, because we've not got so much time. Right, so measure. Let's see whether we can agree on what the area of the circles are. Right, we've got our diameter you've measured as 4.5. Do we generally think that, yeah? So therefore, we think the radius is what? 2.25, right? So let's work out our area. We're going to do pi multiplied by 2.25 squared. So these are in centimetres, just for... Right, can you work that out for me on your calculators?
So 3.4 times.
So we're going to do...
How did you do that?
we're going to do, so I can do pi multiplied by 2.25 squared. It's not plus, is it? So if I couldn't do squared, if I can't do squared, it's not plus, is it? It's multiplied by. Okay? So multiply by 2.25. Okay? And I get the answer 15.90.
So pi, is that how we do it?
No, pi is, I don't see it.
Okay?
Pi.
Yeah, so that if you don't have pi, guys, you can do guys, just look at the difference. If I do 3.14 multiplied by 2.25 multiplied by 2.25 again, we will get a slightly different answer because pi isn't exactly 3.14, is it? It's a lot more, but we can approximate. And so we get an idea. It's not too much different, is it? You think 15.9 or 15.89. It's both, should we say it's 15.9 square centimetres.
On a test, if it's 15.89 and you put 9, leave that as well.
So in a test, what I would suggest, if I ask you to round your answer, you put your answer unrounded first, and then you write the rounded. Put both, right? Don't leave it on your calculator because there's no evidence. So if I don't agree with your answer, I can mark it wrong. But if I see that everything you've done is correct, and you've got something different from me, and then you rounded it correct, I will mark it correct. Yeah?
So now that we have the area for this
Okay.
circle, can we times it by 2 to get
Yeah, because this one is also, it's the same circle, so that's also 15.9 square centimetres. So the two circles together, obviously, like you've just said, 15.9, multiply that by 2, and we get 31.8, do we?
$31.8, yep.
Okay. So that's both the circles. Right. Now, actually the rectangle is now an interesting one. All right? We're going to do it two different ways. So the first way you're going to do is you are going to use your ruler and you're going to measure it, just like you did before. So what's the area of a rectangle?
Base times multiplied by height.
Base multiplied by height, good. Okay, so you need to know, this is super easy, isn't it? So we need to know the height and we need to measure the width or the base or whatever you want to call it. So you measure those, but we are going to have another method to do it. And we're going to check how good our calculations are. Right guys, so we've got two measurements. So our area of the rectangular part is
14.3 multiplied by 9.4.
And the answer is
Something we'll find out.
134.42.
and what are the units?
Centimeters squared.
Square centimetres. Okay.
Square centimeters.
So what is the entire,
Yes.
the surface, what's the surface area of the cylinder then?
Okay, so that means
So we have the circles multiplied by 2 and the rectangle, and we add those together. So what was two lots of the circle? We said it was
31.8.
31.8 square centimetres, plus the rectangle is
134.42.
square centimetre. And so the surface area of the cylinder is
166.22.
166.2. And I'm not checking this. Can you check each other's square centimetre?
Yep, 166.22.
Okay. Right, there's one measurement I want us to check though. right? Which is, not saying you're wrong, right, because we've measured it, but it's this one here, all right, this measurement here, the 14.3. And I'm not checking it because it's wrong. I want to show you how it links to something. Now, when we make our cylinder, what does this edge have to do? How do we make the cylinder? So we cut the circles out, we cut this out, and then we
Fold it.
don't fold it actually. We wrap it around. Now, if you wrap it around, you can actually do this now. Wrap it around, and sort of you can see through it. You can line up the edges. All right. What shape do we get at the end? And what circles are they?
2 equal.
Okay, it's this circle, isn't it?
Yes.
So, what's going to happen then is, do you now appreciate that this line here, what we've got measured as the base, should be exactly the same length as going round the circle? The perimeter. What's another? Circumference. Good stuff, right? Do we have a formula for the circumference of a circle?
Yes,
No.
we do. Didn't we write it down? You said the circumference is. Oh no,
We didn't write it,
we didn't write it, but
so.
we did.
but we did do it. So maybe this is something we could write. The circumference of a circle, or what you would call the perimeter. So the circumference, okay, the formula is pi again. Because remember when we were measuring our donuts and things, I gave you the circumference formula to work out what pi was, didn't I?
Yeah.
Remember we measured around the donut and then we divided that by what? What else did we measure? The diameter, didn't we? You measured the diameter of your donut. You measured. It's pi multiplied by diameter, yeah, pi d. So what we can do, so circumference equals pi d. So what we can do to work this out, we can do pi multiplied by 4.5. And what do we hope we get? 14.3.
14.13. We got 14.137.
Okay. Now,
It's not the same.
it's not quite the same, is
But
it?
it's close.
It's not bad.
If the 1 wasn't there.
So, because we're good MYP students and we are always reflecting and analysing and thinking about
Yes.
things, all right, why are our two numbers different?
Because they're 2 different things.
There could be. Now, so what are our options? There are lots of things to consider. Marley, do you want to- this is the important stuff now. Right. Are these circles perfectly made to fit this?
Yes.
Well,
Maybe not.
it's a bit rough and ready, isn't it? These
Yeah.
are nets, but the lines are a bit thick. We assume they're right, but they
We
might
don't
not be
know.
that accurately made, right?
Yeah.
When we stick them together and cut them out, we might find that they're not quite perfect. And they're not going to be, are they? Because these measurements don't quite match. Well, what's the other thing? Well, pi. Who did 3.14? Who used the pi button? All right. When we measure this distance, were we really super accurate? Because we've got 3 decimal places here, but we've only got 1 decimal place there. So we're trying to be different in our accuracy. So what I'm saying is, did I do anything wrong when those numbers don't match?
No.
No. Right? It's not always that we do something wrong. There might just be something else involved, like, am I able to be more accurate and so on. Okay? So I think we're close enough, aren't we? That length sort of matches going around the outside. So that's an important one. Right? So you've got 10 minutes now. Can I get you to do one definite thing? Can you add the circumference formula into your formula booklet? Done that already? And then you've got a choice. You can either make a cylinder and see whether it works, or you can finish off the other shape you've got.
Wait, so
You can keep the one with the measurements on it. I've got another one for you to cut out. So add the formula for circumference to your formula booklet. Finish off whatever shape you were on, or do a cylinder if you want to get on with a
Mr.
cylinder.
Potts, do I use a new tab?
No, it goes on circle. Go on circle.
He said don't cut it.